result. So that's the conditional queries. That's what we are going to do here. So this is also going to be very interesting. So I want you to pay attention here, and then let's have some fun. Okay, so before we do the conditional queries in Pandas DataFrames, I want us to reload the file. All right, so on the GitHub repo, let's get back here. So on the GitHub repo, the link to this page is in the description box. By the way, I repeat, the link to this repo is in the description box. So when you are here, come to this file, the seek_result.tsv. So click it, you'll be sent to this page, and when you are here, come to raw. You are going to load directly from GitHub. So I'll right click and then go to copy link to copy it, and I'll come and load it here. Right. So I'll just say df, or let me just define it again. I'll say data file, because I'll put everything in double quotes. So I'll paste it, I'll execute it, I'll make sure to print to see the link, and I'm going to load it. All right. But if you already have the file on your PC as well here, then you can also load it using the same approach that I showed earlier on. But I will load directly from GitHub, so that's fine. This file is a small file, so you can load it quickly from GitHub. So that's what I'm going to do. So I'll just say df equals bd.read csv. I'll specify a data file, comma, and I'll indicate a separator. So sep equals /t, everything in quotes, because we are dealing with a tsv file which has tabs as separators. So I'll execute this command to load the file. All right. So now we are going to do the queries. But of course, I'll start with just this one here, df, just to make sure I have some outputs, and I can start with the queries. So the queries is what we are going to do. We are going to select records where log2 change is less than 1. Okay, so I'm going to show 3 approaches, and then these 3 approaches, you can also apply them on the other queries as well. And where there are changes, I'll also let you know. So we are starting with this one. Select records where log2 change is less than 1. All right. Now let's say df.columns. Let's display the column first, and then we can proceed. Okay. So if I'm selecting records, let's look at approach 1. So approach 1, how do I do this? Let me just show it here. So approach 1, I'll say df, I'll bring my square brackets, and in it, I'll say df again. I'll specify the name of log2 change. Then outside that square bracket, I'll say less than 1. We are looking for records where the log2 change is less than 1. So this is it. So you can execute it to get your hits. So you see them here. And you can also save this one output file. You can assign this to another variable, and then save it to an output file. But that's something I will leave to you. Or if you want to learn how to do that, just check the description box. The introductory video that I made on Pandas will help you do that. So that's for approach 1. For this one, let's look at approach 2. In approach 2, the same thing, because we are specifying the columns. It's just the same way we specify columns. So here you can say df, and then we bring our square bracket, and you can say df dot log2 change, right, less than 1. You can execute the command. So that will also give you the answer. So this is for approach 2. Now let's look at approach 3. In approach 3, we use what? df.query. You can say df, that's the data frame, dot query. Then you put everything in quotes. You can say log2 change less than 1. Then we can execute this command. So this will also give us the answer that we want. Okay, so just take note of that. So these are the three approaches. Now let's look at select records. Let me add the select records where the absolute log2 fold change is greater than 1. Let me just edit and put it there. Yeah. So in the second task, you are going to select records where the absolute log2 fold change is greater than 1. So here it's not just a log2 fold change, but the absolute, right, is greater than 1. So if it's absolute, 1 will be 1, that's positive 1. Positive 1 will be positive 1, and the negative 1 will also be positive 1. So let's look at how to do that. So to do that, it's also very simple. Okay, so here I'll just try with one approach, but you can also try with the other approach as well. So let's just do it. So you can say df, bring a square bracket, and then in it you say apps. So apps here is used to find the absolute value. That's the Python keyword. So apps into brackets df dot log2 fold change is greater than 1, like this. So let's execute this command, and that will give us our answer here. So you see all of them here. Okay, so it's so cool. You can try the other approaches as well. So for now, I want you to try and experiment with other approaches. So here, instead of df.log2 fold change, you could have used the one in square brackets. Let's look at it. You can say apps into brackets, and you bring everything here. Okay, so app into brackets, this, and you specify a greater than 1. Okay, so this is also another approach to do it. Now let's proceed. So I'm just trying with one, but you can also try with other approaches. And if you also want some one-on-one tutorials on Python, you can always reach out to me. You can book a session, and we can have some one-on-one tutorials as well. All right, so just make sure to contact me. Okay, so let's proceed. So now I'll move on to this one also. We have select records where PISF value is less than 0.05 and then log2 fold change is less than 1. So here we now have two conditions here, PISF value and then log2 fold change. So I'll give two approaches here. I'll start with approach 1. So let's see how it goes. So approach 1, I'll just say, let me just type it here. Approach 1, I'll use df.query. So I'll say df.query PADJ is less than 0.05. And the end here is important because we have two conditions. And log2 fold change is what? Less than 1. Let me do it here like this. So let's execute this command. So this will give us an answer. And again, you can assign to a variable, you can save this one output file. So that one, I'll leave that up to you. All right. So this is approach 1. Now let's look at approach 2. Approach 2, we'll do this. Approach 2, we say df, okay, and then we bring our square bracket, and in the square bracket we specify the conditions. So we have condition 1 and condition 2. That's going to be the format. All right, now each of these conditions will also be in a bracket like this. Okay, so there's going to be, yeah, this end. Yeah, let me just do it here again. So this is how it's going to be. Now let me go over once again. I'll clear it. So for approach 2, you get your df, that data frame, you indicate your square brackets, and then you have your two conditions. So we have condition 1 and condition 2. And then each of them will also have to be in a parenthesis like this. All right, so this is how it's going to be. All right, so now let's do it. And let me also say that aside the and, you can also use or and then not. All right, so it depends on what questions you are asking. And so currently I'm working on another tutorial where I show how to do queries. So in that tutorial, I will look at all the various scenarios, not just the end. Okay, this one is an intro to let you have a feel of the queries, and then later on we can go into details. So just take note of that. Equals to, not equals to, less than, greater than, all these things can be done. So we look at them in detail in another video. Okay, now let's come back to our query. So let's start. So condition 1 is what? Let's try it. Condition 1 is what? df dot what padj less than 0.05. So you see how it has been done. And say df dot log2 full change is less than 1. So these are the conditions. Now you can execute the command to get your answer here. So we have that also here. So that has been done nicely for you. All right. So this is it. Now let's look at this. You can also do each of these separately. That's a divide and conquer approach. You can split the problem into sub problems, get the solutions, and then combine them. All right. So for beginners, I think that would be very, very helpful. So I will add this. I'll just label it as approach 3. It's the same thing. So you will do this. We are looking for this. Select records where PISM value is less than 0.05 and then log2 full change is less than 1. So I will do this. I'll say condition 1, and that will be equals to what? df dot padj is less than 0.05. All right, that's condition 1. Let me just put everything here. I think that would be better. This is condition 1, and then condition 2 is equals to df dot log2 full change is what? Less than 1. Let's confirm. All right, and now you can bring all of them to it. So you can say df, you bring your square brackets, and then in it you can just indicate your condition 1 and condition 2. All right, so you need to also make sure you have executed each of these. All right, you need to make sure you have executed each of them so that you have your results, and then you can finally execute this also to get your outputs like this. Okay, so this is how we do it. So if the query will be complicated, you can split them into smaller chunks and then solve them, and then finally merge all of them together like this. So this is even easy to understand, and for beginners it's very, very simple to understand and write compared to this one here, which can be complex for beginners. Okay, so sometimes you can just make things simple by splitting the problems into smaller subtasks and then solving them, and then finally aggregating your solutions together like this one here. Okay, so these are cool and interesting things. All right, so that's how we do it. Now let's look at this other query. We say select records where PISM value is less than 0.05 and absolute log2 full change is greater than 1. Now this one, I brought it here because when you perform your differential expression analysis, you may want to identify those genes that are significantly expressed. And one way to do it is to use some thresholds like this to subset them. So in some tutorials, you will see this kind of query where they say you should select all records or gens with PISF values less than 0.05 and absolute log 2 full chain greater than 1. So that means you are going to identify gens that are up and then down regulated. So this is an example of how you can do the subset. So with this one too, because of beginners, we will just go by the simple approach where we split them into subtasks. So I'll start with this one here, condition 1. Okay, so I'll just say condition 1. You can even say condition PADJ equals, okay, and I'll say df.padj less than 0.05. That's the first condition. Then condition log 2 for chain, let me say LFC. That holds absolute value of df.log2 for change greater than 1. And then you can finally combine it. So you can now say df, okay, where you have this condition PADJ and condition, let me just put it here, condition LFC like this. Now you can execute your command. So let's do that now. Perfect. So we have that also done here. Okay, so you can see it's nicely done. Now, if you have already subsetted your problems, okay, then instead of putting your conditions in parentheses, you can do it this way. You can even say df. So we have condition PADJ and condition LFC. And let's just make sure I have the correct names. Okay, and then you can execute them. Okay, so you don't need to now put them in parentheses again because what you are putting is the solution, the output, the result for those conditions. So you can do it this way, or you can also do it this way if, let's say, you are more cautious, you don't want any errors, so you don't want any risk. You can also do it this way to get the answer. Okay, now this is what we have. So if this is the gens that are significantly expressed, then you can also save them to an output file, right? So you can assign this whole operation. Let me just copy it. You can assign this whole operation to a variable. So you can say dgen like this equals, and you paste it there. You can execute it. And you can say dgen.shape to get the number of gens that are potentially expressed. So we have 1591, and you can even save it to an output file. Okay, so to save to an output file, you can say dgen.tocsv, and then you can specify the output file. So you can just give it a name. Let's say dgen.csv. I'll save it as a CSV file, but I can also save it as a TSV. That's fine. So if you want to save it as CSV, you do this, and you can say index equals false. Because here the indexes are numbers and we don't want them. We just want just the records. You can save that. All right. Okay, so if you save it, then you can go and look up for it. Let me see. Mine is here. I've saved it here. There's it. So I can just open it to see what I have. Now, if let's say you are confused, you don't know where your files or where your output has been saved, you can just do it this way. Let me just go back to Pandas. You can just import OS, this Python model. You can say os.getcwd, your current working directory. Then when you execute it, it will show you a path. And so that path is where your output file has been saved. So you can go and then locate that and then get the file. Okay. So if let's say you want to save this as a TSV, then you can also say dagent.toCSV. You give it a name, you can say .tsv, comma, index equals false, comma, sep equals /t. So when you execute it, it's saved. So you can go back here and then see it's there. Okay, so that has also been saved. So these are different formats, but the same information can be found them. Okay, so it's very, very simple and straightforward. That's what we've done. Okay, and then you can do your other queries as well. So I repeat, you can, since this is a differential expression analysis, you can also visualize using some R and then Python packages to generate your volcano plots, generate your MA plots, etc. Of course, I'm tutorials on that as well. So just check the description where you find links to the videos that show how to visualize RNA-seq results. All right. So Python also makes it easy if you want to explore data by using the Pandas library, and that will help you to do lots of stuff. All right. So for those who also want to get a notebook, I repeat, the download link to this notebook is available. So download it, and then for those who also want to support this channel, there are links you can use to buy me a coffee. So I'll see you in the next video.